the element hydrogen forms. Some hydrogen atoms fuse to create helium, as proposed by Gamow and Alpher. 380,000 years later, and light travels through the darkness. The burst of radiation that Penzias and Wilson found happens now. A billion years after the Big Bang, stars take shape, producing the heavier elements like nitrogen, oxygen, and carbon, as Hoyle predicted. Roughly 9 billion years out, matter and gravity combine to form a perfectly typical star. Pressure creates heat at its core. This heat triggers thermonuclear fusion. A star is born. Stellar outflow clears away residual gases. A circumstellar disk of dust remains that eventually accrete into an entourage of planets and moons. One of these lumps of stardust, after being pummeled for eons by residual solar debris, has temperatures warm enough to allow hydrogen dioxide, water, to build up in the atmosphere. Liquid water gathers on the planet's surface. Underwater, mysterious chemical reactions ultimately form life. 13.7 billion years after the Big Bang, our universe is now 156 billion light years across. The sky is full of stars. Our solar system has 8 planets, more or less. The third planet is nearly covered in carbon-based life forms. Some are just realizing what infinitely small specks they are in the grand scheme of things. If you don't understand this process, that's okay. It's the culmination of millions of human brains struggling for thousands of years to figure out how the universe began and where man fits within it. It's enough to overwhelm any one human brain.
If I take seriously the idea that my brain was evolved to be able to throw rocks and pick bananas and stuff, it's pretty remarkable that we humans would be able to figure out much about physics, figure out much about things that didn't have survival value to our ancestors. Yeah, I think it's quite stunning how well we humans have been able to make progress in this regard and not go completely bananas in the process.
This is our story of everything, our world, our solar system, our universe, and how it all began. This is what we think we know. It's a work in progress. The script is still being written, but let's see how it ends. New York City. A beautiful but unremarkable autumn day, like thousands before it, and thousands to come, until there aren't any more autumn days. Imagine for a moment traveling into the future for billions of years. Past the end of human civilization and the lives of all living creatures on Earth. Imagine we are 5 billion years into the future. The sun is running out of the nuclear fuel that gives it fire. As it cools, it expands and reddens, closer and closer to Earth. It swallows up Mercury and Venus. Water on Earth evaporates, and Earth becomes molten again. When the fuel is gone, the sun's core ultimately contracts as it transforms from a red giant to a white dwarf. The expanding outer layers of the sun, called a planetary nebula, drift into space as ghostly shrouds of glowing gas. The planets that survive this process, the outer ones like Saturn and Neptune, are utterly changed by it. The planetary nebula blows away their gassy atmospheres, leaving small, rocky and metallic cores behind. The distant planets, no longer held by the less massive sun's gravity, drift into the vastness of space. Travel billions of years after that, and all remaining heat from the sun has radiated out, and its small, dark surface is the same frigid temperature as the rest of space. The sun is now a black dwarf. Now, billions of years later, propelled by a mysterious and only recently discovered dark energy, the universe expands ever faster, flying apart everywhere. On a grand scale and at a molecular one, expansion overwhelms gravity. Everything rips apart. Not just galaxies, solar systems, and stars, but even atoms. Finally, matter itself is torn asunder. This is the Big Rip, the big rest in peace for our universe, the legacy of dark energy, that stuff we still haven't figured out.
Right now, dark energy is mostly a code word for our ignorance, what this substance is. Some people think it's some sort of stuff. Some people think it's a constant that should be in Einstein's equation. Some people think it's just a reflection of the fact that we might have gotten our gravity wrong again.
Right now, the Big Rip theory of the end of the universe leads the pack. But who can say if this will remain our theory, or if some new discovery will challenge it? The stuff we haven't figured out yet, it goes on forever. One more blow to our centrality in the grand scheme of things. But that doesn't mean we don't know anything. Copernicus, Newton, Einstein, even Alpha, Wilson, and Guth. They've given us pieces of an endless puzzle. They've helped tell us how we fit in the picture.
Recognize that the very molecules that make up your body, the atoms that construct the molecules, are traceable to the crucibles that were once the centers of high-mass stars, that exploded their chemically enriched guts into the galaxy, enriching pristine gas clouds with the chemistry of life, so that we're all connected to each other biologically, to the Earth chemically, and to the rest of the universe atomically. That's kind of cool. That makes me smile. And I actually feel quite large at the end of that. It's not that we are better than the universe, we're part of the universe. We're in the universe, and the universe is in us.
We're not the center of the universe, but we are in it and of it, trying to figure it all out. There's so much we know, and yet so much we still don't know. We hold on tight as our little planet goes hurtling through space, around the sun, around the galaxy, around the universe. Don't forget to look up. There's so much to see, so much to know. Where do we begin?